Hi, today let's try to solve this problem 0, 1 matrix. So we're given a matrix and we have to find the distance of the nearest 0 for each of the cells. So in this first example, we can see that there is only 1 and the distance of 0 from each of the cells is going to be the same. Like for 1 also, the distance of 1 to any of the zeros is going to be 1 and the distance of 0 to itself is going to be 0. In the second matrix, however, let's write it down. We have we have 0 0 0 0 0 0 and no 0 1 0 and 1 1 1. Okay, the distance of 1 to any 0, this 1 to any 0 is going to be 1 itself. Okay, distance of 0 to 0 is 0. Distance of this 1 to any 0 is 1. Distance of this one to any of the 0 is again 1 because you can see that the 0 is right there on top. The distance of this one to any of the zeros is however 2 because here 1 2 or 1 2 or 1 2, and the distance of this one to any of the zeros is again 1 here. Okay, so we have to find the shortest distance of 1 to any of the zeros. One way is first thing is they ask the shortest distance. So BFS is going to be much more helpful than DFS. Okay, because in BFS we can find the shortest distance from a node to another node. Okay. But if you see, one way we can do it is whenever we encounter a 1, we can do a BFS and find its value. So here 1, the BFS of this is going to return a distance of 1. Okay, similarly a BFS of this one is going to return a distance of 1. BFS this one is going to return a distance of 2. Okay, this is one way to do it, but in this case for every cell we have to compute the BFS. And we are not doing it for every cell, we're doing it for any time a cell's value is equal to 1. Suppose a cell is contains all ones. 1 second, I think there should be at least 1 0 in the matrix. There's at least 1 0 in the matrix. Even in this case, if something is like this, we have to calculate BFS of this, BFS of this, BFS of this. So time complexity is going to be extremely high. Okay, instead of this, let's say we are not trying to modify the existing matrix, but we'll use another distance matrix, and this essentially will we'll have to return this, and this will be the minimum distance of 1 to any of the zeros. So here 0, whenever it's 0, the dist mat is going to be 0. Whenever it's 1, let's say whenever it's not 0, like in this case, let's give it as a max value. Okay, now one way we can do it is every time we encounter an 1, what we can do is we can find the BFS and we can update this dist mat accordingly. So here while doing this, we can find that the distance of this to this is going to be some x value. Similarly, the distance of 1 to any value is going to be an x value. So we can simultaneously update this matrix. And a way to simplify this more is find the distance, but because every time a distance of I will change based on a distance of based on a distance of 0, right? So from 0, let's put all the zeros into the queue, all the indexes of 0 into the queue, and update the other values accordingly. Like once we try to perform a BFS of this, and whenever we find that, suppose we're doing this and we find this value is going to be equal to 2, we're doing BFS of this is going to be 2, this is going to be 3, this is going to be 4, and this is going to be 3. Okay, so this done is done. Now we pop this value, and now we find the BFS from this. In this case, this is just going to be 1, this is going to be 2, this is going to be 3, this is going to be 3. So all this is fine. So we can see that these values became correct. Simultaneously, we'll find BFS of this. Here we don't have to update this since 1 is going to be less than 2. Similarly, we find BFS of 0. And when we do this, this is going to be 1. So at the end we find BFS of this, and this is going to be 1, and at the end we can just return the dist matrix. So let us try to code this up. I hope the logic is clear. Okay, so let me just find the length of the matrix NNM. Okay, now let me try to find the dist matrix. Okay, and here every time it's 0, it's going to be 0, else it's going to be infinity. So let us update the original dist matrix. Okay, now if matter I comma j is equal to 0, in this case the dist matrix is also going to be equal to 0, else the dist matrix is going to be integer or max value. Okay, I hope this part is clear. Now what we can do is simultaneously, when we're doing this, we have to add it to the queue, right? Because from there we have to find BFS from each 0. So let me create a queue, and this queue will contain the indexes. Okay, so whenever we encounter a 0, apart from updating the dist matrix, we also have to push it into the queue. Okay, I comma j. Okay, now our main thing is to find the BFS. At the end anyways we have to return the dist. Okay, and while finding BFS, right, let's have a dist temp, and this is equal to 1. Now while q dot is empty, while q is not equal to empty, let's find the size of the queue. Okay, and now while size is greater than 0, what you can also do is you can do size minus minus, and here this temp will also be plus plus. This is basically the distance of 0 to any of the ones. Okay, now let's get our coordinates, our initial coords, which is going to be q dot pole. Okay, and now we also have to maintain the directions, right? We can either move up, down, right or left. So let's just maintain that. We'll use a dir array. Okay, so for up, down, right, left. Okay, now let me do this. I press this. Now let's have a new x, which is going to be chords of 0 plus dir of I comma 0, and int new y is equal to chords of 1 plus dir of I comma 1. Okay, now one thing is, let's check if any of these coordinates are valid. There's a a possibility that we can reach the end of the matrix and it can go out of bounds, right? So let's just first make sure nothing is out of bounds. Okay, and now if the dist which we calculated till now is less than, initially it's everything is integer on max, right? If it's less than whatever is present in the dist array, then let's update the dist array. Okay, and simultaneously let's offer it into the queue. Okay, I hope this is clear. Now let's just run it. Okay, let's submit it and see if it works for all test cases. Okay, looks like it did pass. So I hope this is clear. Thanks everyone for tuning in. Bye bye.